So go here, where? Settings, developer settings. Very good, Somalika. Do you see? Personal, select this. This is the last one. And can we create a token here or not? Yes. Need to. Okay. So Terra token, give the same name. So give whichever the requirement you have, and then click on here, generate token. Do you see this token here? So that token you take it here. Right? And then what is the resource here? What's the resource type? GitHub underscore repository. Example, GitHub repository, Terraform GitHub repo. Description, visibility is public. So for this, what you need to do first? Because by default, if you're using AWS, it will download AWS plugins or not. So in this case, which plugin it will download? GitHub plugins it will download. Got it? Got it online? You can do it. If you want me to run, I can also do this for you. So ls. So I have a lot of things here. Let me go ahead and then delete the entire Terra. Okay, mkdir Terra. Okay, and then vi main.tf. So do you see this? Provider GitHub, and then save it. What I need to do first? Terraform init. So it has Terraform has initialized, and what we need to Terraform? Let's do validate. Validate is also completed, and what we do now? Terraform apply. You can do it. Auto hyphen approve. So what it is creating now? It is creating what? GitHub repo. What it's creating? Oh, offline. What is creating? GitHub repo. So what's the name of the GitHub? Do you see TF GitHub repo, right? So if I go to my home, right? If you go to your repositories, you see just how it created Terraform GitHub repo. So if you want to destroy it, you can destroy it. So remember, AWS is not only the provider, you can have multiple providers also. Example, GitHub. So in another provider for fun, I have mentioned it. Before I go to that Docker provider, so there is also something called what here? Local provider. What is it? Local provider. So local provider. Yeah. Local provider meaning, as the name clearly says, it is not connecting to anything. It is just local to the machine. What is it? It is just local to the machine. For example, main.tf, vi main.tf. These are all small topics. Can you tell me what is doing? What's the provider block? What the block it is? Local. What is doing? It is creating a file locally and putting some content inside it. Simple as that or not? So these are the different types of provider. I showed you AWS provider, I showed you GitHub provider, and I showed you here local provider. So if you run this, what will happen? There's so many providers available. Missing provider. Now what I need to do? Terraform init. So Terraform validate. Okay. So now if I do Terraform, what? Apply. Okay, this is delete. Not found. Okay, that's fine. No, it has deleted. So it has not destroyed. Yeah, that's fine. So that's fine. So now what you do? If you do, you see this here, test.txt. If you do test.txt, do you see the content is there or not? So this is all called here local provider. What is this called here? Local provider. And one more provider here, I mentioned here, not here. We have Docker. Which one? Can you create Docker containers also using Terraform? Tell me. Can you create a Docker containers also using Terraform online? So if you want to create any files locally, modify the scripts, create a script, Karthik, right? We can go with the local providers, right? Okay. So let's remove that directly completely. All that. Okay. Okay. Sorry. So I have the code here. You can go and ask in the chat GPT also. So to get the code, so just give me the code. I wrote a nice code for you. Just give me a second. Terraform with Docker. If at all you want to integrate Docker with the Terraform, and can you integrate Terraform also with Jenkins? Yes or no? So in Jenkins, set up a Jenkins and then integrate Terraform. But Terraform can also go and create the Docker containers or not? Yes. So for that, first of all, what we need to install? We need to install the Docker in the machine. After that, what we do here? So this is your Docker block, provider block. What is here? This is the provider block, and this is the Docker backend. So this is predefined. If you go to the Docker, you'll get it from here. So if you go to our what's that Terraform providers, you go for the Terraform providers. If you want Kubernetes, you can go for it, right? Okay, we can search it also. Right? Container orchestration is also there, right? Yeah. So we have this, see, a lot of things, for example, here, and we have the code here, right? This is Dockerless, like you have your Docker. So here I grab the code also from there. This is the provider block. And okay, let me take this out and put it in the chat, and you tell me what it's doing. Okay. Okay. So the Terraform and provider block is clear for you. Can you please check the resource block and tell me what it is doing? You can easily understand this code. Online, you understood, Anna? Tell me, yes or no? Everyone online. Easily understandable or not? So now you understand. Don't need to worry about the code. If you want to, let's say, if you want to change the image name, can you change it here? If you want to create a I mean, if you want to change the container name, can you change it? And can you in ports also mapping? Can you change it? Everything you change it or not? So here provider block is constant. Yeah, ChatGPT, Dinesh. Okay. So do you see this here? I use ChatGPT to get it, and also you can use the official documentation. So from the Terraform. So from the Terraform also, you just type here Docker. You see this here? This is the one which I used here now. Always go with the official documentation, right? Let's say, for example, create Docker container, for example. So here we are, right? Sorry, these are we are checking the providers. So it contains only the providers, but you can go with the official documentation and then create it. I'll share that to you. Don't worry. Okay, see here. So what is your resource? Docker image, Docker underscore image, which is the image I'm using, Nginx, and name is Nginx : latest. Keep locally, so it removes the image when the container is deleted. If you want, that is optional. And then you see resource, what you are creating here, container. What is the label here? Nginx. What is the name of the container? Nginx container. And you need to call that image or not? How do you call the image? Docker underscore image dot Nginx dot, which one attribute is image ID. And then when you are creating a Docker, we need to expose the ports or not? So internal inside the container it is port 80, and outside it is exposed to the port 8080. And what is the output I'm showing here? What's the output I'm showing here? I'm showing the container name. I'm showing the container ID, and then URL, right? So URL is our EC2 instance URL or not? This one. Okay. See here now. So if I go clear Docker ps -a. Okay, when to start the Docker, what's the command to start the Docker? System ctl start Docker. Okay. So now if I do Docker base, do we have anything? And we have Docker images. We don't have any images. So now do Terraform validate. So missing the provider. Yeah. Yeah, you're answering. I thought you were asking some question. Okay, so first what we need to do? Terraform init. Initialize or not? And then what we do? Terraform validate. See, our code is success. And then what we do? Terraform. Let's see plan what it shows. What is showing? It is creating container ID and it is creating the container image and name. So Terraform, which one? Apply ---- auto approve. So what will create now? It is creating the image and also it is creating the container and it is deploying the application inside it, and then it is done. If I do Docker images, I have the image or not? If I do Docker ps -, yeah, it's working or not? So if I go ahead and then take this and it exposes with what port number? Port 8080. Welcome to Nginx. We got it. See how easily we have integrated Docker to with the Terraform. Online clear? Na? Online clear? Yeah. Yes or no? Can you integrate Kubernetes? Can you create pods also? For that, what do you need to create first? What do you need to set up? Kubernetes cluster you need to set up. Once you set up a Kubernetes cluster, for example, if you set up a Minikube or KOps, so I have given a code here. So what is the provider now? You should use Kubernetes. And then all the time you need to go with the config file here. And then see, it is creating a deployment. See, replicas, selectors, remember? Manifest file. And you're creating a service for it. And the service name is what? Load balancer. And you have the load balancer also. Nice. Online. Clear on the providers. So it will be really fun. Set up a Minikube by yourself and then run this Terraform. Now, if this Terraform is able to integrate with multiple providers, can we simply integrate this to our Jenkins or not? In Jenkins, you need to add one plugin, Terraform plugin. What's that? Terraform plugin. That's it. And then write a pipeline, Terraform validate, Terraform plan, Terraform approve. So you created two variables. Apply, destroy. Build with parameters, is there? No. In Jenkins, apply, because we need to either apply or destroy, right? So I'll write it while executing the pipeline, select apply and then build. And it will create the entire infrastructure. What the Terraform needs, only the files. TF templates are readily available or not? So put all the files in the GitHub. All the Terraform files in the GitHub and give the GitHub in the pipeline. And then Terraform validate plan, apply. As the files are available, so Jenkins will create its own workspace. What is the default workspace for Jenkins? What? Jenkins workspace. Warlibs Jenkins workspace. And then you will get the job name, and inside it all the Terraform files will be downloaded, and Terraform will execute all the files. Understood? So it is easy to integrate with Jenkins or not Terraform? Super. Online, can you give me a CC on this, please? Super. So just now we have seen different types of providers. So now let's move to the next topic. Yeah. Version constraints. It is just a small topic. There's no practice on it. What is it here? Version constraint. As the name clearly says, what is this here? Version. Where are we using the version? Plugin versions are there, no? Which is the version we are using now? Version number 5.91. Yes or no? 5.91. Let's say you're maintaining the entire infrastructure using Terraform. Which version you're using? 5.91 something. Now, AWS has implemented some new services. Does the Terraform 5.91 has those plugins? The new services related plugins? No. So what do you need to do again? You need to change the version or not? You need to change the version. Let's say you are using the old versions. So you need to upgrade the versions or not? So like this here, you can get the versions. And here you see we have the Terraform block, right? So version here you can give greater than, less than, whichever the versions that you need. So based on that, Terraform will automatically upgrade or downgrade the versions and do Terraform init. Here what I'm using is greater than or less than. That is greater than or less than. This one. This one is greater than or less than. Less than only. Which one? Less than. Right? So now if you put this code, your Terraform, the version will get downgraded to this or not? Because 5.90 is the 91 is the latest version, it will get downgraded to 5.56. So if you have a requirement to downgrade or upgrade, so you can use this version constraints. You can use greater than or greater than or equal to, less than or equal to, input that particular version. Because some features of AWS will work with only some versions. For that reason, you can change the version constraints. So just now we learned about the local providers or not? Yeah. Okay. So next one is Terraform refresh. Say that. Say that. As a name, clearly it is, I said it what? Danger. I should not teach this, but yeah, but please keep that in mind. Don't apply in your real time. It is damn dangerous. Okay. So what this refresh command will do is, in Terraform, the Terraform refresh command is used to update the Terraform, which one? State file to reflect the current state of real world infrastructure. That meaning what? You understood? What is it? Okay. Assume from Terraform you have launched 5 EC2 instances. How many? 5 EC2 instances you have launched. But in your AWS console you have 50 machines. Only 5 machines are managed by Terraform. In Terraform state file, how many resources will be there? 5. We have 5 or 100. You didn't understand. Listen carefully. From Terraform, I have launched 5 EC2 instances. How many? 5. In the AWS console, assume that I have 100 machines. In that 100 machines, I have only 5 machines which is managed by Terraform. Yes or no? In Terraform has state file, no? In the state file, how many resources information will be there? Only 5, right? If you do Terraform refresh, all 100 resources will come and sit in the Terraform state file. It is better to go and die instead of troubleshooting that. You need to remove the resources one by one or not? Remember, I showed you how to remove the state list, resources, right? So for that reason, this is a dangerous command. So I'll give one example. Let's do that. See, this one, you know, what is it doing? What is it doing? Launching the EC2 instance. What is the name of the EC2 instance? Ria server. Okay, simply I'll run this. Did I destroy it? Did I destroy Docker? No, right? Let's destroy that. So I destroyed the Docker. See how simply it deleted everything. Okay. So now which one I need to use? Main.tf. So I'll remove main.tf. Vi main.tf. Again, my provider got changed or not? So what I need to do? Terraform init. You understand when to use Terraform init? Huh? By keeping this headset morning to evening here for your classes, morning classes, evening classes, in office, headset, my skull, what the shape changed, and my hairstyle got to change. See? By putting that morning to evening these many years, if I do Gundu, what will happen? That headset mark will be there maybe. Yeah, my hairstyle changed with that. It's got become curly with that headset. Okay, fine. Don't worry about my hairstyle. Okay. What I was doing? I destroyed. So main.tf. Okay. Terraform init I did, right? Now what I do? Already you got married, no problem. Self-maintenance, why? Yeah. Don't make it public, Dinesh. Okay. So I lost my control where I am. Terraform what? Okay. I put it right. Okay. Terraform done. Okay. So okay, it is success. Now what I do? I'll do Terraform apply --, auto -- approve. Tell me what it'll do. It will launch one EC2 instance with the name Ria server. See here, I'll show you. Now what I do after this? Guys, now what I do after this? I went to the AWS console, change that Ria server to student server. What the Terraform will understand based on that. Okay, now I will do that. See. Okay, sorry, where is that? Ria server is there. Now what I do? I change this to, for example, student. Our DNA. Okay, no problem. Okay, like this. Now tell me what is the feeling of Terraform? What is there in Terraform state file? Guys, in Terraform state file, what will be there? Did it change? Okay. Now if I do Terraform apply, now what happens? Change to? Yes or no? Online, tell me now. If I do Terraform apply, what will happen? It will change or not? Because Terraform will blindly follow the state file. What does it indicate state file? Ria server. So it doesn't matter. Whatever the state file, you're going to apply it. You'll go and apply it. Okay, let's check. Okay, what has happened now? Change back. So what will happen? So is it good to change it manually on the AWS console? Don't do it. While the Terraform is managing, do not change it. But if you have changed it here, right? But you have changed it here, again based on the Terraform state file, it will go and update into the AWS console. You got the point? If you edit the state file, then chudu, chudu, right? Don't see the state file, right? So you should not edit the state file. Remember, it's not good. Okay, now what happens is, hold on. So if I do Terraform TF state, what it shows? What it shows? Now I'll go and modify this to student DNA. Okay. Now still it's showing here, but I'm not doing Terraform apply. If I apply, what will happen in console? It will change. Now what I do? Terraform. I do this. What will happen? And then if I do cat Terraform state, it is dangerous or not? Huh? People like you and me, I log into the AWS console, and for fun, I keep on changing all the tag names. If you are intelligent, what you do? If you do again Terraform apply, everything will come back. But Pusuk, if you do instead of Terraform apply, if you do Terraform refresh, that nasty tag names, everything will come and sit here. But if you have Terraform versions in S3, can you get it back or not? Can you get back your previous environment? Be careful. Yes. So remember, for that reason, you need to have the 100% versioning for your backend state file. And that too, if it is good to have the backend as S3, don't keep it local. That's why I told you in the starting days only. I taught you about local state and then remote state. Okay. So how to roll back again? So what to roll back here now? Your state file got changed here. So there is no concept in this, right? Again, if you want to go back, you need to modify the state file, or else what's this thing? What you do here again? This is bad to do it. I'm telling you. So if you do Terraform refresh again. So if you do Terraform apply, what will apply? It will again student DNA, it will apply. It will not do any changes because it is same, Karthik. So you see, its name is same here now. So if I do cat Terraform, yes. Okay, now it got updated here. So if you want to get back to your again RIA server, anyways, in the main.tf, we have given RIA server only. So if you apply it again, you'll get the RIA server. Yeah, correct, Karthik. Guys, is it clear now? Now tell me, will you remember this refresh command? So if at all, let's not use refresh command. But if you want to import, we already covered the import, right? We already covered the import. We have removed the state file. We have removed the resource from the state file, and then we have imported it again or not? Yeah. So, and also I showed you how to import multiple resources. So Terraform supports multi-import. Tell me, does the Terraform support multi-import? Answer is no. So Terraform supports only one by one import. Terraform import, and then you put the resource type and then label, and then you put the instance ID or whichever it is, and one by one you need to import it. Is it possible to bulkily import using Terraform? No. I told you there is one tool which will import bulkily. Which one is that? There is a tool I told you to. Terraformer. Say that. All I put it in the chat. Terraformer. Terraformer. Okay. So if you want to go with the Terraformer, so guys here you can install Terraformer. Okay. And then what we do, we will launch the 3 EC2 instances manually. Assume that you have the AWS resources, which is not tracked by Terraform, which is manually launched. And can we import the entire AWS to the Terraform or not? Yes. So what we need to do here? So Terraformer, instead of writing Terraform, so you need to write here Terraformer. Which one? Import. Which one? Which AWS? Which resources you want to? EC2 instance in which region? If you do this, automatically the entire resources will be tracked by the Terraform. And it is not only one EC2, sir. I want to go with all entire VPC, entire everything. You just keep on put instance, VPC subnet, everything, whatever is there, everything bulkily it will download. It will track it. So just quickly, I'll show. Correct, Karthik. Terraformer.sh. Let's install this first. So meanwhile, let's go and launch a couple of EC2 instances. So first, let me destroy this. Terraformer ---- version. So you need to do source --rc. Now it worked. Okay. It will do both. Let me show you, Karthik. Let's do. Okay. So before that, let me go ahead and then destroy. So I'll go and launch few EC2 instances. Launch more like this. So I'm not just giving the names. Okay. Okay. And how many machines I'm launching here? 3 machines. Assume that you have 300 machines also, no problem. Okay. So all the 3 machines are coming up. Okay. So simply what you need to write? Let it destroy. So let me write. You also might face the issue. So Okay, it destroyed. Okay, so what we do? So now we have our EC2 instance ready. Let's go and check. So those are running already. So what's the command now? Terraformer. Say that. Terraformer. Which one? Import. Which provider? AWS. And then resources. Which resources? EC2 underscore instances. In which region are those? In which region are those? Maybe. -1. Okay. So if I do this, let's see. What is this? It's not supporting a EC2 underscore instances. Instance. See here. So those are still coming up, right? Those are still coming up. It is initializing. So let us. Okay. It's already done. Let me remove Terraform. Okay. So cat Terraform state file. Okay. All the machines are up. Okay, those are up. So let's go and run it again. Okay. So what it says? Read resource responses now. Okay. With just only instance. It's already imported. No. Karthik, that was wrong. Okay, that real server, that is okay, that's fine. That real server that was terminated, right, by the Terraform, that you can ignore that. That's fine. And you see, there is a directory called generated. Go inside this cd generated. If you do ls cd AWS ls cd, which one? EC2 instance ls. Do you see this here? Karthik, it has created instance.tf. Your configuration file is there. Your terraform.state file is also there. So cat terraform.state file. See. So now it has imported everything or not. So if you want to bulkily import, not only if you have 300 EC2 instances also, it will import all 300. If you have VPCs also in that particular region, whatever the VPCs you have, bulkily it will import everything. So guys, you want to check, but this code will not be like your normal readable language, Karthik. So if you are interested in instance.tf, so it will be like this. It has downloaded everything. You see? Okay. Sorry. Clear now how to import. So when this will be useful, when you want to track your entire infrastructure using Terraform, then you can use this tool called what? Terraformer. Online, no? Is this clear, please? Online. Let's write Terraform. Okay. Okay. So I'm just removing everything here. Yes, correct. Okay. Done. So you can use Terraform test also with the generated code, right? So I'm just okay, that's fine. Is this clear till here before I go to the next topic? Online. What are the things that we have learned? Providers. Today we started with what? Providers. So we have seen local provider, GitHub provider, Docker providers, right? And also we have seen what? After that? Online. Refresh command we have seen. Terraformer, how to import bulk resources we have seen. So now let's go with the very important topic, which is called modules. Say that. Very important. What is that here? Online, put in the chat. Modules. Say that. Now here, meaning instead of writing the code, how you are writing the code till now, main.tf, you are putting the entire stuff. Yes or no? And maximum what you're doing, you are separating variables.tf, provider.tf, backend.tf, output.tf. Yes or no? If required version.tf, you're separating. But all your code in the main.tf, you're putting VPC code, EC2 code, S3 code, everything in the main.tf or not? Everything you're putting in the main.tf. Instead of putting all the different resources in one single main.tf, what we do is we will create a separate directory for each service that is called modules. Same thing we have done in somewhere. Anyone remember? In other tool we did this. Same name. Let's see who has that power to remember. Ansible modules. Very good. Which one? Ansible modules. So guys, remember, Dinesh, in real time, there will not be a possibility of deleting your main.tf files. If you're doing that, you are fired. But just we need to be secure from our side or not. And that's the reason whatever the code that you are developing, everything should be inside your GitHub. Remember, what we did, what the developers will do, developers will develop the code and put it in the GitHub. GitHub is a version control system or not. So whatever the code that you are having, the Terraform is the code, right? So whatever the code that you have developed, you should not put it in the machine. You should put it where? In the GitHub. Just in case if someone delete also, we can recover it or not. Yes or no? So there will not be a possibility of someone delete it. But just in case if you delete main.tf and if you have only state file, again, this is a very big headache. You need to import it one by one and write the main.tf again. If you want to automatically generate, again use Terraform to generate it. So understood the concept of modules, same concept that what we have learned in Ansible. Guys, in Ansible, what we created separate directories, right? For packages, separate directory. For files, separate directory. For services, separate directory. For users, separate directory. And then we called all these modules in the main file or not? Do you remember? Online, do you remember? In Ansible. Something. In Ansible, you created. So Malika, if you forgot how we'll maintain your interview, So in real time, not in real time, in Ansible. Lingarity, good. So use 3 command also that to see all your files, right? Ansible files, playbooks, right? YAML files. Okay, same concept here also. We call it as Terraform module. There we call it as Ansible modules. Here we call it as what? Terraform modules. Simple enough. For VPC, create a separate directory. For EC2, separate directory. For S3, separate directory. Now call that modules in the main.tf. Will you write everything in main.tf or there individual module main.tf? Individual module have their own main.tf, variable.tf, output.tf, everything. EC2 has main.tf. I gave, yeah, see. This is a project for you. See here, main.tf will be the main file. It is called parent root module. What is it called? And what are all these called? Child modules. Say that. Yeah, child module. And do you see here, we need to create a directory called modules. Inside that one more directory, EC2 instances. And then EC2 instances, what we have here? Main.tf, output.tf, variables.tf. For S3, main.tf, output.tf, variables.tf. For VPC, main.tf, output.tf, variables.tf. For all, there will be only one state file and one main.tf. Guys, you understood? Online, you understood? It is not inheritance, but for, let's say, for example, if you want to do any changes, you can do only, let's say I want to do only changes to EC2 instances. Do I need to modify my main.tf? No, just go and modify here. So in real time, we'll be using these modules because it will be easy to manage and easy to use it. Yeah. Got it? Two methods. One is go and create the directories individually. mkdir. First, what you need to install? 3 command to see it. So mkdir -p modules inside this. -p modules S3 bucket. -p modules this. If you want to create manually, create it. But I have given everything inside our GitHub. So what you do is just clone it and then let me show you that. GitHub. So it is modules project. I think you guys have already forked it. Only 14 members forked. That meaning those many people have done the practice. Okay. So remember last time you did this VPC EC2, right? So now you can go for what? Modules project. See here. I gave you this project last time, and now this is I told you inside this what you are creating modules. Inside that again, how many directories you have created? 3 directories. In each directory you have main.tf, output.tf, variables.tf. For S3 also same. For VPC also same. For all we have only how many root module? Only one, which is main.tf. If you open main.tf, what does it contain? See, you know this provider. What is the module? What is the block I'm putting it here? Module block. Which one? What is the module name here? VPC. And where is your module? /module/VPC. Similarly, EC2. You're calling EC2 module and passing the variables here. S3 and outputs. But if you want to see what is there inside individuals, here in EC2 instances main.tf, what do you have? Only the resource block. And I use your variables.tf. In variables, guys, see, it's up to you how do you manage the project. I showed you multiple ways. I showed you keeping all the code in main.tf. I showed you keeping the values in variable.tf. I showed you separating the values in which file? Which file? TF vars. Which file? Yes or no? Can you implement the same concept here also? Yes, but here I didn't put TF vars. So what I put here main.tf, I'm calling the variables. All the variables I have declared over here. But did I put any values here? No. Values I'm putting in my root directly. I'm passing in the root. It's up to you, right? I can pass it directly in main.tf, or else you can put TF vars inside the individual ones. And you don't need to put all these things here. Just call the variables here. That's it. Guys, you understood? Online. You're getting the modules concept. Online, no? Very good. Very good. You're able to understand the code easily? So this is the project for you to do it. So here it will take a lot of time for me if I want to write everything one by one. So what you have to do is, so clone it and then keep it aside and try to write by yourself. One time you write it. Like how you wrote VPC, and another one, module structure, you write it once, and rest of the code in coming days, those are all, you can copy paste the templates. But to make you understand, so I wrote it here clearly here. Create a directory individually. Create the files, create the directories individually. Correct. So create the directories individually, go inside the directory, cd inside it. So I don't give this to you. Okay. Okay, see here. So create the individual directories here. In each directory, go to cd modules, EC2 instances, and how many files you'll create? 3 files. And code is where? In your GitHub. Go to GitHub, my GitHub, and then go to main.tf. First you need to write main.tf, variables.tf. So first you need to write what? Variables. So declare all the variables, write down, and go to main.tf and write the resource block, call the variables. And output.tf, what you want to output. So this EC2 instance is done. And next go to S3 bucket, create these 3 files, and then write the code. Modules, create this 3 file. And finally, what you need to have? We need to write a root module. So root module main.tf. So vi main.tf. So this is the main.tf. In this main.tf, you mention the block called modules. What do you know? Will you able to do this project? Online? Yes. Simple, right? Online, will you able to do this project, please? Practice, a lot of practice. Logically, you understood everything, right? So do this and come tomorrow, and tomorrow we'll go with the next other topics. And we'll be doing one 3-tier architecture project. Okay, you know to write the code. So what's the output that you get from here? Tell me, by seeing this, what's the output that you get? By seeing this code. After executing this code, what will you get? One VPC will get created. Inside that VPC, EC2 instance will be launched. S3 bucket will be created. So the output will be EC2 public IP address and then S3 bucket ARM. Okay. Online. Any questions? Will you able to do this project? Modules project? There is also something I wrote for you. Terraform 3-tier project. This one for sure you cannot write with your hands because it has a huge code. But if you want to write, you can write, no issues. You see how much code. So this entire code, this 3-tier, what? Do one thing. Do one thing. This 3 guys online, please open your GitHub and then for this repository also. Yes, exactly said. That's what I told you. If you understand the logics of the Terraform, it is easy for you. So do that modules project, and then for this, go through these ones. Don't do it. Okay. But if you have time tomorrow, entire days, you can do it. There's nothing. What you need to do simply Terraform, apply and destroy it only. But what you need to do is here, go to main.tf and then try to understand the code. What is there? Nothing. We already learned this. This is the form of project. You can do it by yourself. Provider, what is creating here? VPC, it is creating a subnet. It is creating another subnet and application subnet. 3-tier project. Load balancer. Right? In the backend, RDS also will get created. See, RDS will be there, application server, web server, load balancer. We already did this in AWS a lot. But this is through code. Just try to go through this once. Do it. Okay. Manually don't do it. Okay. Don't write it because you'll go mad if you write all these things. So, but try to understand it and then take it. Okay. Online. So 2 projects are there for you. Will you able to do it? State well corrupted. Huh? Very good. But if you say this in real time, no. Okay, Nana, any questions? So you have today's practice. Today's practice, providers, Docker, all these things. Kubernetes also there for you if you want to do it, right? And then what do you do? Module project is there, and then 3-tier project. So you have lots of hands-on tomorrow. Please complete it and come. So mostly we are mostly done with Terraform. So tomorrow, a few topics are left. We'll go with that, and then from day after tomorrow onwards, we'll do the couple of projects which is related to your